Hi everybody, Mr. D here. Just checking in and wanting to review some calculus for IBSL level exam paper prep. The question is number 14. Here it is as it appears on the exam paper. We're given the velocity of a particle as a function, and we're asked to sketch on the grid provided, and then find the t-intercept and the total distance traveled. So there's the question, and keeping in mind this is a paper 2 question. So here we are. Here's the actual function. We're asked to sketch it in a given domain. So that will help us come up with the window for the x scale values. So there's our domain for x. And given the grid that I just shown you, the range is from -2 to +2, so that helps with the y settings as well. So I'm going to go ahead and just demonstrate what that would look like once we've gone through the plotting of the function y equals e exponent sine x minus 1. In the window settings, I've gone ahead already and established our domain 0 to 5, going up by increments of 1. And I've gone ahead and used the scale on the y-axis that was provided, and I went ahead and graphed it. It's important to note that when graphing on IB papers, the key values, the intercepts especially, and the max values are actually adjudicated and rewarded marks. So it's important that you come up with the precise location. So in the case of this x-intercept, notice that it's 1, 2, 3, and a little bit. So it's important that you acknowledge that on your sketch. So here we are. Here's my version of the sketch. And again, notice how I've shown that that intercept is just beyond the 3, and that the maximum value is not quite at 2. And I've demonstrated that as well. It's just below a maximum of 2. And it happens between 1 and 2 some point. And I've gone ahead and done that. My y-intercept happens to be at 0, and I've gone ahead and illustrated that. So the next question was to find the t-intercept, and that can be done using our GDC as well. You can go ahead and use the second calc feature and look up a 0, and there ahead you just trace along the sketch or the graph, hit enter, go to the other side of the 0 and hit enter, enter again, and there's our t-intercept. Well, this number looks very familiar, 3.14159. It's basically pi. So you can choose to write 3.14, or if you recognize that it's in fact pi, you can go ahead and illustrate that. Please note that you need to be in radians in your mode for trig functions. In this case here we have sine in the exponent, so we definitely need to ensure that we're in radian mode. Otherwise your function will look a little bizarre or peculiar, and you want to make sure that if that happens on an exam, you go back and adjust your mode. So moving ahead, the last part of that question was find the total distance traveled. Because this is a velocity time graph, and I guess we could have, or should have rather, labeled the axes. That would have been a clever thing to do. At C, we were asked to find the total distance traveled from time t equals 0 to t equals 5 seconds. In these kind of questions, it's always good to consult with the formula booklet just to see if there's anything there that will help us get to the solution quicker. And sure enough, we have the total distance traveled formula from time 1 to time 2 is given by the absolute value, or modulus, some people refer to that as, of velocity function. So we were given the velocity function, and we're interested from 0 to 5. This is a paper 2, as I've been reminding you. So we can actually go over to our GDC and type in the actual antiderivative of the modulus, or absolute value, of e to the exponent sine x minus 1, making sure that the minus 1 is not in the exponent, which could be a common error. So you have to hit the right arrow to get down to the regular location, minus 1, and the variable of integration has to be the same as the one in the function. Once you hit enter, the GDC will take a moment. It's a fairly complex operation it's doing, and it'll come up with the final answer of 3.94. Just an aside, if you're interested in a little GDC background, where do you find antiderivative? That's under the math menu. Scroll down below the more frequently used functions until you get to the function integration, and you get the blueprint for what we just entered, or what I did in advance. You go ahead and enter the lower bound, hit the right arrow, upper bound, hit the right arrow again to get inside the actual brackets. And now you have to go to the math menu again, but it's under the NUM is where you find the absolute values. You hit enter there, and then you proceed on your way. And like I said, make sure you enter the same variable in each. And there you have it, 3.95 to 3 significant figures. So you go back to the exam booklet using the graphing display calculator. I provided a sketch, which is a good thing to do. You can even shade in the area between the function and the x-axis, because after all, that's what the antiderivative does, or the integral solves for you graphically. And there's the end of that question. Hope you enjoyed that. If you have any questions, keep them coming in, and I'll do my best to provide solutions for you.